This is the third entry on a series of discussion videos on the topic of concavity and the second derivative test. So in this video, let us answer the second exercise problem. We are being asked to determine which critical numbers satisfy the hypothesis of the second derivative test and apply the test to these numbers. So for item A, we are given the function f of x equals x raised to 4/3 minus 6x raised to 1/3. Okay, to start, let us first compute for the critical numbers of f. So we know we can do this by computing the first derivative of f. So the first derivative of f is given by 4/3 x raised to 1/3 minus 2x raised to negative 2/3. Okay, the critical numbers of f then is given by the zeros of f prime and by the values of x, which makes it undefined. Okay, so definitely x equal to 0 makes f prime of x undefined. So x equal to 0 makes f prime of x undefined. Also, we should solve for the zeros of f. So the zeros of f is given by, so let us solve for the zeros of f prime. So f prime of x is 0 implies that 4/3 x raised to 1/3 is equal to 2x raised to negative 2/3. And so this implies that x is equal to 6/4 or 3/2. Okay. So another critical number for f is given by x equals 3/2. 0 of f prime. Okay. However, which of these critical numbers satisfy the hypothesis of the second derivative test? Okay, let us recall. Let me just pull it out quickly. So let us recall that the second derivative test is only valid for critical numbers that make the first derivative of f equal to 0. So you cannot use the second derivative test for critical numbers which make f prime of x undefined. Okay. So that means that the only critical number we can use is x equals 3/2. Therefore, we can only use x equals 3/2 for SDT for the second derivative test. To use the SDT, let us compute for the second derivative of f. So the second derivative of f is given by 4/9 x raised to negative 2/3 plus um, 4/3 x raised to negative 5/3. Okay. And therefore, f double prime evaluated at the critical number 3/2 is equal to 4/9. 3/2 raised to negative 2/3 plus 4/3 times x, or 3/2 raised to negative 5/3. Okay, so we don't actually need to simplify this expression. We only need to know that this is always positive, or this is positive. Then the second derivative test tells us that uh, the critical number 3/2 is actually a relative minimum. Therefore, f has a relative minimum at x equals 3/2. Okay, so by SDT. Okay. I'll see you in the next video. We shall answer item B.